In this video, I'm going to use this Inkscape to go through actual presentation of a solution, like I was trying to explain in the earlier video, is going to be actual experience. So I'm not going to skip or anything. The actual explanation will go, and so that it help you to experience as an audience. Because of this blocks there, audience kind of expects or get more curious about what's in there. So I find it is interesting. So let's start. The first problem is for a position. States the following. For a position function of time t, what is the physical application of higher order derivatives of the position function? The answer is written here. You click on that and getting attention. The answer was position and the derivatives of velocity, and the derivative of the velocity is acceleration, and acceleration is called second derivative of a position function. So that would be an example of higher order derivatives. And the second part of the problem says the following. For the graph y equals f of x, what could be a good applications? Good applications of higher order derivative of a function f of x. And I didn't break down into certain pieces. A straightforward answer is that for the graph, we use the values of these approximations for linear approximations and quadratic approximations. So that was a simple conceptual problem. Next part is more computational problem, and see on how you experience this. Function is given by square root of x. Part A, compute the linear approximation Lx of a function f of x at c equals 4. So the solution's over here. The first part is actually stating the formula, the general formula of linear approximation, not actually using anything like that or c equals 4. It's a general formula. So general formula goes like this. Linear approximation is the function value plus the derivative value multiplied by x minus c. Here, x is the variable of this approximation function. C is fixed. You can see c is given in here. The choice of this good c, good value of c is something to think about. And here it's simply given. So we're just going to use it without talking about why it's a good choice or something like this. So that's a general formula, and c is given in here. Next thing we're going to do, we have to just find this value, just two numbers, and linear approximation is just there. So to get to that, we need a formula of f of x and f prime of x. Formula of f of x is already there. So I wrote it down. Let me go ahead and do that thing. So the function is there, y equals square root of x. And here I'm going to rewrite that into x to the 1/2. So that I can use this power rule when I compute the derivative of this one, right? This is enough again just to get that value, but we want that, so I write it in that form. So in the first hand, we're going to write it in this way. If you apply the power rule, 1/2 comes down, and if you subtract 1 from the exponent, you get negative 1/2. It's just direct application of that derivative rule. And we write this one in more familiar form, 1 over, because negative exponent is a reciprocal. So this is more familiar way of writing this expression so that I can compute this value at c equals 4. All right. What is this part going to be? This part is actually, we use this formula f of x and f prime of x and this version and that version to actually get this value when c equals 4. So what is it when c equals 4 there? C equals 4. What is f of c? 4 and root 4, and that's 2. So that's why we have f of c equals 2. So that's going to replace that. Second part is the derivative value of this one. When c equals 4, plug in c equals 4 there. We use this one. It's more comfortable, I think. Many people will be more comfortable with this one. The 4 there is 2 times 2. So 1/4 is the value down there. All right. Now we have everything. F of c, that's supposed to be this part, is going to be replaced with a 2. So that's why this part is 2 here. F prime of c, that's 1/4. So that replaced this 1/4 and leaving this x minus c. And c should be replaced with 4 there. So that part's that. So that's the full answer for part A. Compute the linear approximation of this function square root of x at 4. Because we chose this 4, this value and that value is something we could compute by hand. Square root of x is involved, and square root of x is involved here again. So at 4, you know it's a perfect square, so we can um, compute that by hand. That's the whole purpose. Why are we doing this? Square root of x, if it is not perfect square, it's difficult to compute. This linear approximation is valid for those x value that is close to 4, things like that. So x equals 4, of course you get 2, but if it is a 4.1, this plugging in this value in here, you get a good approximation of the square root of x. And this right-hand side of a linear approximation at the moment is something we can compute by hand easily, a lot easily than computing square root of x by hand. And there's a way to do that, but this is nicer approximation. Next problem is problem number 7. And first problem states the general formula of a quadratic approximation denoted by qx, function f of x at c. So that's the formula part in there. So I'm going to actually change that. I'm going to show you the first bit of it. And this is something we talked about already. This is, if I just give you this much, that was precisely our linear approximation right there. Quadratic approximation keeps this linear approximation and has one more term. And what is that one more term? That involves a second value of a second derivative. And the tricky part is that you'd have to throw in this 2 in the denominator. All right? Use different video to understand why the 2 has to be there. All right, so c is again given 4, just like before. So we need to have a formula of f of x and f prime of x. Fortunately, this one is the same function as before. So on that part, it's going to be a repeat, but this part is not. So this spot is our original function f of x. Again, rewritten in the exponential form so that we can apply derivative rule easily. So when I apply the derivative rule, and we have that. This is something we already saw that read in the earlier problem, so I'm not going to explain it. But the second part is this part is the second derivative. And if you differentiate this expression one more time, d dx down there, and you will arrive there. Why are we doing this one in the part B? Because it says is asking us to compute that. But if you look at the big picture, this seems like our goal. We need the value of that. We need the value of this one. We need the formula of a double second derivative. And this is what we're doing. First derivative differentiated again. That's the second derivative. So let's differentiate that. And this is a constant multiple 1/2. We're differentiating this one. So you can see negative 1/2 comes down. And then you have to subtract 1 from the exponent. So that's the first level. So if you simplify that one, you can see that's negative 3 over 2. So that's x to negative 3 over 2. That together is negative 1/4. All right. So that's probably the right road. And use this negative exponent becoming reciprocal. So that's the form. So if you're not familiar with this part, to get to this f prime of c, then you have to change that to radical. This 2 in the denominator change to square root, and 3 in the numerator is actual power part. So we have a formula of f double prime of x as well. All right, that answers the part B. And part C, use part A and B, these information, to compute the actual quadratic approximation qx. And here's a quadratic approximation. You have to replace these c's and f of c, f prime of c, f double prime of c divided by 2 with actual values. So here, I think it is f of c, so it is f of 4. We already did that, and this one as well, so I skipped that part. This part in here, We have to calculate f double prime of 0, plug in x equals 4, and I got to this part because it's more familiar expression. So to do that, let me double prime of here, plug in 4 in there, and that's what we have there. Let me just go ahead and delete that. All right, negative 4, 4 in there. The square root of 4 is 2, 2 raised to 8. I think that's 32. So negative 32, that's this value. Remember, there's 2 down there, so you have to further divide this one by 2. That's going to be multiplied down there by 2. So qx, first term, f of c is replaced by that 2. Second term, 1/4, is going to appear as a coefficient. That's again the linear approximation. That is going to replace this part with a 2 in the denominator. So that is actually negative 64 in the denominator there, and minus squares. So that is the full answer. And I think it's a pretty nice way to present something that's already prepared, and it's efficient, and it's somewhere in between um, PowerPoint presentation of showing one step at a time and versus actually writing it. I don't know. I think there's a certain charm to it, and I think you can um, keep the audience attention along the way. Thanks.